Welcome to day 9 of Advent of Code 2024. So this is called Disk Fragmenter. So we meet up with the amplipods again. For you who did day 23 of Advent of Code 2021, you might remember those amplipods. So one of them needs your help compacting files on its computer hard drive. So you get this disk map. It looks like this is a kind of a line with integers in a dense format. So, and this will then include both the disk, both the file size and the blank space. So if we look at this smaller example here, we got kind of and we have the first file here. We indicate that but with ID 0, but it's one block long. We have the second here, it's blank space, so we have 2 blank spaces. That's 3 blocks long. We indicate that with a 1. Then we have 4 blank spaces, which will be the 4 blank spaces here. And the last one is 5, which will be ID 2. Yeah, so so the process here is kind of moving those blocks so that there are no gaps in between the file blocks, and we need to rearrange them that way. So looking at this example again, we can see that this here we have like here if we look at this again, we will start by moving this 2 to the leftmost free space, so it will end up here. Next 2 here will end up here. Then this 2 here can end up here. This 2 will end up here, and this 2 will end up there. And this is just another example, but this is the actual example input. So this is how it looks with the example input. Then obviously running the real input is a much larger one. Okay, and the final step is actually calculating the checksum. So what we do is we assign a file ID which we always start at 0 and then go 1, 2, 3, and so forth. So we need to calculate the checksum we calculate by the file ID multiplied by the file's index. So you can see here, like if you take this example here, we have this is 0 multiplied by 0, which will be equal 0. Then we will have 1, which is the index 1 here, to multiply by file ID 0, still be 0. Then we have we have the index 2 multiplied by the file ID 9, which would be 18. And we have the 3, which is the next 9, multiplied by 9, 27, yeah, and so on. So this is how the checksum is calculated. So let's go to the code. Yeah. So initially I actually planned to, I was actually filming my my live attempt on solving this problem, but somehow that video got corrupted and didn't work. So, and then I had already finished it, so yeah, there was no way to go back. So I would just explain the code instead. So obviously we first read in the input, just a long line of text. Then the fragment by blocks method here actually calculates the result for part 1. So the first thing we do here in the first part here is that we parse out the files and also the blank spaces. So we kind of, this is kind of the first part of it, that we kind of take this x here will be the current char. We will parse that to an integer. That will be the length of the file. It will also be the length of the blank space when it's a blank space. And we indicate the blank space by -1. So, and when it's an even number, it will be a file, and when it's an odd number, it will be a blank space. Then we take those, then we will select out all these blanks from that from the disks. And the last part here is actually compacting the well, in this part here we actually do the actual moving of those. Like if you go back to the for example here that's where we actually do this kind of moving the file blocks. Yeah, so in the end we just do that checksum calculation. So we take the index multiplied by the file ID. So the disk in this because we will always have the file ID first and the index for it, yeah. So so this will be our part 1. Just to illustrate a little bit further, I can actually just show you how I grouped it all together just in a visual way more. So here we are running on the test data here. Yeah, so so if we jump past this block, so the disk here will now contain our input here. So I mean here we have file 1 is 2 blocks, 3 blocks of blank space. File 1, 3 blocks, 3 blocks of blank space. File 2, 1 block, blank space, 3 blocks blank space, and yeah, and so forth. So that is how I grouped it together. And then we will have the blanks. These will just contain the blank, the actual indexes in the disk list where they are. So we're going to loop through these blanks. We're going to try to move the disk, move the blocks, and into every possible white blank space, and then remove all the blank space that we don't need after it. And then in the end, we just calculate the sum here. So So let's just run up to here now. Yeah, so so let's go back then to our problem again. So this will I can just show you that this gives us the correct answer for part 1, which is 1928. Okay, so let's go to part 2 there. So in part 2 here, so we can see now that they have a lot more contiguous free space, but it might not be that good of idea to fill up that to actually fragment up that file system in this way, because the computer is now running more slowly. So, but the eager Ampipoda also already has a new plan. Rather than move individual blocks, he liked to try to compacting the files on the disk by moving whole files instead. So this time attempt to move whole files into the leftmost span of free space blocks that could fit the file. Yeah. Yeah, so this process looks a bit like this. So let's say that we have this as an example. Well, I mean this is the example data actually. So then we will take this file here, try to move it, and we can see that it fits here. Then we will take the 8. Then those doesn't fit anywhere, so they have to stay. Then the 7 fit there, and so forth and so forth. The 44 will 666 will 6 will not be here. 44 can move down to here. Yeah, and now we can actually move the 2 down here. This way, in the end, we will still have a little blank space here. So in this way we will have we'll end up with this instead. Then we will obviously try to compact to remove unnecessary blank spaces as well. So let's look at how that code is formatted. So this is my part 2 code. So now we have a dictionary for the file, which is position and size. We will also have the blanks with its start and its length. So, and the first part here is still to parse out the blanks, the files and the blanks. But now the thing is that what we need to do is actually a little bit, and why I have this condition here is actually if we end up with a file that has a length of 0, we could end up messing up our computation. So then I will just throw an exception here, but it doesn't happen for my input, and I don't think it will happen for any input. But it's good to actually have these kind of checks for these edge cases sometimes, so that you don't end up with a strange result in the end. Because this is not something that should happen. It's not supposed to happen. Yeah. So when we have our files and blanks, we will then go through the files. So we're getting the position and size, the position of the current file. We will then go to our blanks, and we will have our start and length of start index and length of our blanks. So now we actually have two conditions here then. So if the blanks starting index is greater or equal to the file's position, then we remove all the blanks that we don't need anymore. And if the size is less or equal to the length of the file, then the file will fit in that slot. So then we move the file to that slot. We also if the size is exactly equal to the length of the file, the size of the size of the file is equal to the length of the blank, I mean, then we remove that blank. Otherwise we will actually move the blanks by the size of the file and the length, and also decrease the length by the size of the file. So and also one other thing, that both of these conditions will break, because these conditions can't both happen on the same iteration in this code. Yeah. And then this is just calculating the checksum, but will most basically be the same thing as before, and we just return the total. So that will give us the answer for part 2. So let's just let it run. Oh, something has happened here. I think my computer has some issues right now. Let me just pause. Yeah, sorry for that. I just had too much running on my computer, so yeah. So let's just check the last result here. So the part 2 is part 2 here is the test data, and this is the real data. Yeah. Now I think I need to restart my computer here, because it's acting really strange. So this is actually all for day 9. So let's check back tomorrow then. Bye bye.